Hi everyone, this is 7th grade Elevate lesson 61. Today you will be constructing tape diagrams. The first part of this intro I wouldn't focus too much on at all. It is just a recap on everything ratios, from how to write ratios, how to read ratios, how to work with ratio tables, how to find constants and proportional relationships. Your main focus lies here. Okay, so the lesson is on tape diagrams. So here is what I would brief students on before you jump into your model. It says that tape diagrams are another way to represent ratios. Tape diagrams use blocks to represent the quantities or amounts. To determine missing quantities of fruit, a tape diagram can be useful. So when you have not been given a visual aid or you have not been given physical pictures of apples and oranges, you can draw a tape diagram. So it says we found that for every 2 apples, Simon needs 1 orange. So here is the tape diagram that I have drawn, right? For every 2 apples, you can see here, there are 2 apples in yellow. Anytime I have 2 apples, I also have 1 orange. They go together. This is 1. But I now have to use this tape diagram to figure out what happens when I actually have 8 apples. So that can be represented by making copies of the tape diagram block set. So again, this was 1 block set, right? And in this 1 block set, I have 2 apples. So let me go ahead. This is my 1 block set with my 2 apples and my 1 orange. Let me make another block set. Now I have 4 apples all together. Let me make another copy. When I made another copy, now I have 6 apples all together. When I make my last copy here, I end up with 8 apples. So if I have 8 apples, then that means that I have 1, 2, 3, 4 oranges. Okay, it's the same thing like saying this image has been copied 4 times. Once this image has been copied 4 times, I end up with 8 apples and 4 oranges. What happens when I start out with 2 apples and my 1 orange, but I want 6 oranges altogether? So start out with 1 orange, but I want 6 altogether. So here's my first 2 apples, 1 orange. If I make a copy, now I have 2 oranges, 3 oranges, 4 oranges, 5 oranges, 6 oranges. Here are my 6 oranges based on my copies. Once I have 6 oranges, that means altogether I also have 12 apples. That is the same thing like saying I started out with 2 apples and 1 orange, and then I multiplied by 6. I multiplied each of my values. I multiplied my apples by 6 and I multiplied my oranges by 6. In this example, I multiplied my oranges by 4 and my apples by 4. Okay, so from this example, I honestly would jump to your teacher model for 6 minutes. And we're going to go through this together. So it says the ratio of green to red candy pieces is 2 to 5. So green to red, we talked about this in a previous lesson. Order matters. So because green is first, the first number in my ratio is tied to green. Green is 2 and red is 5. So this has already been done for you, but we want to draw for students that green is 2 and red is 5. This is not going to be proportional. Here we go. This is the ratio. Sorry. 1 second. they tell you that there are a total of 84 candy pieces in the bag. So I want you all to show students ratio tables for this example, because students have worked with ratio tables. We're going to bring it back so it can help us with our tape diagram. So we talked about having green to red being 2 to 5, right? So green candy pieces is 2, and then we have 5 red candy pieces. If I have in one bag 2 and 5, that means I have a total of 7. But they are telling me that there are a total of 84 candy pieces. That means I need to find an equivalent ratio. So I need to figure out how I get then. So I'm going to make another row of my ratio table. And I want to ask myself, well, how do I get from, I started out with 7 total pieces. How do I get from 7 to 84? I get from 7 to 84 by multiplying by 12. 7 times 12 gives me 84. So that means that each of these pieces is 12. Here's your 12, here's your 12, 12, 12. Each of these pieces is 12. Same thing. Each of these pieces is equal to 12. Now, it's already been done for you here, so students will just have to fill it out. Now, based on the model, we can figure out how many candy pieces there are, how many colors, how many total colors there are within those candy pieces. So in a bag of 84, and I want to figure out how many green candy pieces I have, I would need to add up my 12. So I have 2 12s. 12 plus 12 is 24. And then I have 5 12s. 5 times 12 is 60. So in a bag of 84 total pieces of candy, maintaining my ratio of 2 for every 5, that means I have 24 green and 60 red. 24 green and 60 red. Now, if I were to add these two numbers up, I would get 84, so I know that my math is good. Now, here it says, complete the table to represent the number of candies that could be in the bag if the ratio of green to red candies remain the same. And we have worked on this in previous lessons. We have our starting ratio 2 and 5, and so we're just going to use that to help us solve, right? So if we're finding missing values, so for instance, we're finding the missing value of red for this particular question, well, then we need to use the information that we do know. We know that 2 times 3 gives me 6. So because I multiplied by 3 on the green side, I also need to multiply by 3 on the red side. And then 5 by 3 gives me 15. This question also gives you space to make your own problems. However, question 5 asks you the question, if there are 32 green candies, so making sure you're putting the 32 in the green, how many total candies would be in the bag? How many total candies? So even when we did this work, we did it wrong. So it says how many total candies would be in the bag. So 32 green, we have to ask ourselves, how do we get from 2 to 32? By multiplying by 16. So if I multiplied by 16 on the green side, I need to multiply by 16 on the red side. 5 times 16 gives me 80. But it asks me the total. It doesn't ask me for the number of red candies. 80 is the number of red candies. It's asking me for my total. So I need to add 32 plus 80. And that is going to give me a total of 112 total pieces. So from there, you'll launch students into their student practice, have them use their ratio tables to help them understand the question. And then for today, there's no exit ticket. Today, for their fluency, students will have to divide fractions they're going to use the keep, flip, change method or keep, change, flip method to solve, which is fine. They're multiplying by the reciprocal. It's going to take them some time to do it. So have them choose a column or tell them which column to work on and then go over maybe 2 or 3 of those questions before jumping into your mini lesson.